Okay, let's go. Number 1, the Chicxulub impact. About 66 million years ago, give or take 11,000 years, an asteroid roughly 10 to 15 kilometers in diameter, traveling at about 20 kilometers per second, struck the Yucatan Peninsula. The impact released about 100 million megatons of TNT worth of energy, roughly 2 million times the Hiroshima bomb. The asteroid vaporized on contact. The target rock vaporized. In seconds, a temporary cavity about 30 kilometers deep opened in Earth's crust. The cavity collapsed. The rebound created a peak ring structure. The final crater measured about 180 kilometers across and 20 kilometers deep, larger than the state of Connecticut. The Yucatan Peninsula's continental shelf was permanently reshaped. The northern edge of the Yucatan block subsided, the southern rim uplifted. The entire regional geology was restructured in minutes. Schultz and colleagues calculated the ejected distribution in 2010. Vaporized rock, molten droplets, and shocked minerals were launched into ballistic trajectories. Some may have reached escape velocity. Most fell back. The global ejecta layer is detectable on every continent. Luis Alvarez and colleagues identified it in 1980 at the Cretaceous-Paleogene boundary. Iridium concentrations reached about 10 parts per billion, roughly 100 times background levels. Shocked quartz, formed only under pressures exceeding 10 gigapascals, is ubiquitous. Tektites, glass ferrules formed from vaporized rock, are found from Haiti to Texas. The impact triggered global wildfires. Soot layers in the boundary clay suggest roughly 15 to 25% of terrestrial biomass burned. The atmosphere filled with sulfur aerosols from vaporized evaporite deposits. Dust and soot blocked sunlight. Photosynthesis stopped. Within weeks, temperatures may have dropped by about 10 to 15 degrees Celsius. This is the impact winter hypothesis. About 76% of all species went extinct. Non-avian dinosaurs were annihilated. Pterosaurs disappeared. Paul Wren and colleagues demonstrated in 2013 that the Deccan Traps flood basalts in India were erupting at the same time. The main phase of Deccan volcanism happened within about 50,000 years of the impact. Courtney Sprain and colleagues refined the chronology in 2019 using high-precision argon-argon dating. The largest Deccan eruptions occurred within about 50,000 years before and after the impact. The debate is unresolved. Did the impact alone cause the extinction? Or did Deccan volcanism weaken ecosystems first, making them vulnerable to the impact's final blow? Gerta Keller has argued since 2011 that Deccan volcanism was the primary driver. The impact, she contends, was catastrophic but not sufficient on its own. Schultz and colleagues countered in 2010 with a synthesis of 41 research groups. The impact, they argued, was the kill mechanism. Deccan was secondary. What is not debated is the crater's existence. The Chicxulub structure sits buried under about 600 meters of sediment on the northern Yucatan Peninsula. It was discovered in 1978 by geophysicists mapping gravity anomalies for petroleum exploration. Seismic reflection surveys image the crater's internal structure. The peak ring is visible. The multi-ring basin architecture is preserved. The impact melt sheet, about 3 kilometers thick in places, has been mapped. Hildebrand and colleagues confirmed the impact origin in 1991 using shocked minerals and melt rock geochemistry. The crater reshaped the Gulf of Mexico's northern margin. The Yucatan platform structure, its faults, its sediment distribution, its hydrogeology, all bear the impact's signature. The asteroid that killed the dinosaurs did not just cause an extinction. It physically rebuilt a continental shelf. But 66 million years ago, another force was already reshaping a continent. Not in seconds, but over millennia. Number 2, the Deccan Traps. Around 66 million years ago, the Indian subcontinent was being rebuilt by volcanism. Not explosive eruptions, fissure eruptions, flood basalts. About 1.5 million cubic kilometers of basaltic lava poured across western India over roughly 640,000 years. Enough lava to bury Texas under about 8 meters of rock. The eruptions were driven by a mantle plume, a column of superheated rock rising from deep within the earth. When the plume reached the base of the lithosphere, it melted. The magma found pathways to the surface through massive fissures, cracks hundreds of kilometers long. Individual lava flows ranged from about 10 to 50 meters thick. They stacked. In some places, the total thickness exceeded 2 kilometers. The lava flows created the Deccan Plateau, covering about 500,000 square kilometers of western India. The Western Ghats, the mountain range along India's west coast, are the eroded edge of this volcanic pile. The continental crust was physically rebuilt. The topography was rewritten, but the atmospheric impact was cool. Anjali Schmidt and colleagues modeled the sulfur dioxide emissions in 2016. Each major eruptive pulse released roughly 10,000 gigatons of sulfur dioxide into the atmosphere. Sulfate aerosols formed. Global temperatures dropped by about 2 to 4 degrees Celsius for decades after each pulse. This is volcanic winter, not from ash from sulfur. The timing is critical. Paul Wren and colleagues established in 2015 using argon-argon dating that the main phase of Deccan volcanism overlaps the Chicxulub impact within about 50,000 years. The largest eruptive pulses occurred immediately before and immediately after the impact. The debate over causation has been running for decades. Gerda Keller has argued since 2011 that Deccan volcanism was the primary extinction driver. The impact, she contends, was catastrophic but struck ecosystems already devastated by volcanic winter, ocean acidification, and habitat loss from the eruptions. Her evidence includes marine microfossil assemblages showing gradual decline before the impact and abrupt collapse at the boundary. Schultz and colleagues countered in 2010 with a synthesis by 41 researchers. The impact, they argued, was the kill mechanism. Deccan weakened ecosystems, but the impact delivered the final blow. Their evidence includes the global iridium anomaly, the abruptness of the extinction in terrestrial vertebrates, and the synchronicity of the boundary layer worldwide. What is not contested is the eruption scale. Radiometric dating using uranium lead and argon-argon methods places the main eruptive phase around 66.25 to 65.61 million years ago, with a margin of error of about 40,000 years. Lava flow geochemistry shows distinct pulses. Magnetic polarity reversals within the sequence allow correlation with the global magnetic timescale. Mercury anomalies in marine sediments provide an independent volcanic proxy. Eric Font and colleagues identified mercury spikes in 2016 at the Cretaceous-Paleogene boundary, consistent with massive volcanic degassing. Sulfur isotope ratios in marine sediments show atmospheric sulfur loading consistent with Deccan emissions. The debate over eruption tempo remains unresolved. Was the volcanism continuous or pulsed? Did individual eruptive episodes last years, decades, or centuries? Courtney Sprain and colleagues argued in 2019 that the eruptions were pulsed, with 4 major phases separated by quiescent intervals. Blair Schoen and colleagues proposed in 2015 that the eruptions were more continuous, with sustained lava effusion over hundreds of thousands of years. The physical evidence supports both models in different ways. Modern analogs exist. The Laacher See eruption in Iceland in 1783 released 120 million tons of sulfur dioxide over 8 months. It caused crop failures across Europe and an estimated 6 million deaths from famine. Laacher See was only about 0.01% the volume of the Deccan Traps. The Columbia River basalts in the northwestern United States, erupted around 17 to 15 million years ago, are a closer analog. They cover 163,000 square kilometers and represent about 200,000 cubic kilometers of lava. The Deccan Traps are about 7 times larger. The Deccan eruptions reshaped a subcontinent. They may have contributed to the worst mass extinction in 66 million years. And the mechanism, flood basalt volcanism driven by mantle plumes, remains active. 65 million years later, water would prove equally capable of reshaping a continent. Not lava, not impact. Ice. Number 3, the Missoula floods. Between about 15,000 and 13,000 years ago, the Pacific Northwest was carved by water. Not gradually, catastrophically. Glacial Lake Missoula formed behind an ice dam created by the Cordilleran ice sheet in what is now northern Idaho and western Montana. At its deepest, the lake was about 600 meters deep. It held roughly 2,000 cubic kilometers of water. The ice dam failed. The failure mechanism is flotation. When the water level rises high enough, the ice dam becomes buoyant. It lifts. The seal breaks. The lake drains. Victor Baker documented the flood mechanics in 2009. Peak discharge may have reached 10 times the combined flow of all rivers on Earth. That is about 17 million cubic meters of water every second. The water traveled at around 100 kilometers per hour through the Columbia River Gorge. The floods carved the channeled scablands, about 40,000 square kilometers of erosional features across eastern Washington. Massive coulees, dry waterfalls, giant current ripples, hanging valleys, erratic boulders the size of houses. Dry Falls in central Washington is about 5 times wider than Niagara Falls. During the floods, the water towered to roughly 10 times Niagara's height. It is now completely dry. The floods did not happen once. Richard Waite identified evidence for at least 40 separate flood events in 1980 using rhythmite sequences, alternating layers of fine and coarse sediment in glacial lake deposits. Each couplet represents one flood cycle. Brian Atwater expanded the count in 1986. Some estimates push that number close to 100. The ice dam reformed after each drainage. The lake refilled. The cycle repeated over roughly 2,000 years. Each flood reshaped the landscape. Each flood deposited erratic boulders, scoured bedrock, carved new channels. The erosional power is visible in the bedrock. Streamlined hills, scabland topography, potholes drilled into basalt by swirling floodwater carrying boulders. Giant current ripples, sediment waves about 15 meters high and 150 meters apart, are preserved in the Camas Prairie. They formed underwater during peak flow. Jim O'Connor and Victor Baker modeled the hydraulics in 1992. Flow depths in the Columbia Gorge reached about 120 meters. Flow velocities exceeded 30 meters per second. The floods transported boulders weighing hundreds of tons. Erratic boulders from the Canadian Rockies are scattered across the Willamette Valley in Oregon, nearly 1,000 kilometers from their source. The landscape you can drive through today was built by these floods. The Columbia River Gorge, the Palouse region, the scablands of eastern Washington. J. Harlan Bretz proposed the catastrophic flood hypothesis in the 1920s. He was ridiculed. The geological establishment favored gradualism. Catastrophism was considered unscientific. Bretz spent decades accumulating evidence. Erratic boulders, dry waterfalls, streamlined hills, giant ripples. In 1979, at age 96, he was vindicated. The Geological Society of America awarded him the Penrose Medal. The catastrophic flood hypothesis was accepted. The evidence is unambiguous. Varve counting in glacial lake sediments provides a chronology. Sediment grain size analysis shows the energy required for transport. Hydraulic modeling confirms the discharge rates. The debate now is over the number of floods. Waite argued for about 40 floods, while others think the number may have been closer to 100. The mechanism is understood. The ice dam fails when buoyancy exceeds the dam's structural strength. The lake drains in days to weeks. The dam reforms as the ice sheet advances. The cycle repeats. Modern analogs exist. Glacial outburst floods, Yerkalops, occur in Iceland when subglacial volcanic eruptions melt ice dams. The 1996 Grimsvötn eruption produced a flood peaking at about 50,000 cubic meters per second. Lake Missoula's peak discharge was about 340 times larger. The floods reshaped a region the size of Massachusetts. They carved features visible from space. They moved enough sediment to bury a city. But the most catastrophic reshaping of a continental margin happened underwater, and it drowned a civilization. Number 4, the Storegga Slide. About 8,150 years ago, give or take a century, roughly 3,500 cubic kilometers of sediment collapsed off the coast of Norway. About 95,000 square kilometers of seafloor gave way. An area larger than Ireland slid into the deep ocean. The slide was not instantaneous. Seismic reflection profiles show multiple failure phases, but the main collapse happened rapidly enough to generate a tsunami. The mechanism is methane hydrate destabilization. Methane hydrates are ice-like compounds that form in marine sediments under high pressure and low temperature. They stabilize the sediment. When they destabilize, the sediment loses strength. Tor Bugge and colleagues documented the slide mechanics in 1987. The continental slope off Norway was oversteepened by glacial sediment deposition during the last ice age. When the ice sheets retreated, isostatic rebound altered pressure conditions. The methane hydrates began to dissociate. The slope failed. The tsunami struck the coasts of Scotland, Norway, and the Shetland Islands. Stein Bondevik and colleagues identified run-up deposits in 2005. Sand layers in coastal peat bogs and lake sediments deposited by waves roughly 20 to 30 meters high. Radiocarbon dating of plant material above and below the sand layers places the tsunami at about 8,150 years ago. Consistent with the slide age, the waves traveled across Doggerland. Doggerland was a land bridge connecting Britain to continental Europe across what is now the North Sea. During the last glacial maximum, sea levels were about 120 meters lower. The North Sea was dry land. As the ice sheets melted, sea levels rose. Doggerland shrank. By about 8,150 years ago, it was a low-lying coastal plain. Marshes, river valleys, lagoons. Mesolithic hunter-gatherers lived there. Vince Gaffney and colleagues mapped Doggerland's topography in 2009 using seismic reflection data. They identified river channels, lakes, coastlines. The landscape was habitable, productive. The Storegga tsunami inundated it. The run-up deposits in Scotland show wave heights of roughly 20 to 30 meters. Doggerland's elevation was less than 10 meters above sea level in most areas. The tsunami would have swept across the entire region. Stone Age settlements were destroyed. The survivors became refugees. Doggerland did not disappear immediately. Sea level rise continued for another 2,000 years. But the tsunami accelerated the process. The land bridge was severed. Britain became an island. The trigger mechanism remains debated. Some researchers argue the slide was triggered by an earthquake. The Norwegian continental margin is seismically active. A magnitude 7 earthquake could destabilize the slope. Others argue methane hydrate dissociation was the primary driver. Isostatic rebound after deglaciation reduced pressure on the hydrates. They destabilized. The slope failed. Carl Harbitz and colleagues proposed in 2006 that the slide occurred in multiple phases over several hours. The tsunami was generated by the main collapse phase. What is not debated is the tsunami's impact. The sand layers in Scotland are unambiguous. The radiocarbon dates are consistent. The bathymetric mapping shows the slide scar. Modern analogs exist. The Grand Banks earthquake in 1929 triggered a submarine landslide off Newfoundland. The slide generated a tsunami that killed 28 people and severed transatlantic telegraph cables. The 1998 Papua New Guinea tsunami was generated by a submarine landslide triggered by a magnitude 7 earthquake. The waves reached about 15 meters high. More than 2,000 people died. Similar slopes exist off Norway, California, Hawaii, and the Canary Islands. They are monitored, but prediction remains impossible. The Storegga slide reshaped the North Sea. It drowned a land bridge. It turned Britain into an island. But 66,000 years earlier, a different kind of eruption nearly ended humanity entirely. Number 5, the Toba eruption. About 74,000 years ago, give or take 2,000 years, the largest volcanic eruption in 2 million years detonated in what is now northern Sumatra, Indonesia. A VEI-8 eruption. About 2,800 cubic kilometers of dense rock equivalent were ejected into the atmosphere. The eruption created a caldera about 100 kilometers long and 30 kilometers wide. It is now Lake Toba, the largest volcanic lake on Earth. The ash traveled globally. Greg Zielinski and colleagues identified Toba ash in Greenland ice cores in 1996. In India, ash layers as thick as 15 centimeters were found nearly 3,000 kilometers from the source. Ash deposits are detectable in marine sediments across the Indian Ocean and South China Sea. The tephra geochemistry is distinctive. High potassium, high silica, specific trace element ratios. Every ash layer with this signature traces back to Toba. The atmospheric impact was catastrophic. Michael Rampino and Stephen Self modeled the volcanic winter in 1992. Sulfate aerosols and ash blocked sunlight. Global temperatures dropped by roughly 3 to 5 degrees Celsius for 3 to 5 years. Regional cooling in some areas reached 10 to 15 degrees Celsius. Photosynthesis collapsed. Plant productivity crashed. Herbivore populations declined. Carnivore populations followed. Stanley Ambrose proposed in 1998 that the eruption created a genetic bottleneck in human populations. The evidence is mitochondrial DNA diversity. All living humans show remarkably low genetic diversity compared to other great apes. The coalescence time, the point at which all modern human mitochondrial lineages converge to a common ancestor, is roughly 70,000 to 80,000 years ago. Y chromosome analysis shows a similar pattern. Human populations appear to have crashed to somewhere between 3,000 and 10,000 individuals. Ambrose argued Toba was the cause. The volcanic winter killed most humans. The survivors were isolated in small refugia. When populations recovered, they carried reduced genetic diversity. The hypothesis has been contested. Michael Petraglia and colleagues found archaeological evidence in 2007 that contradicts the catastrophic bottleneck model. Stone tool assemblages in India show continuity across the Toba ash layer. No evidence of population collapse, no evidence of technological regression. The tools below the ash are Middle Paleolithic. The tools above the ash are Middle Paleolithic. The same technology, the same people. Chad Yost and colleagues analyzed pollen records in 2018 from Lake Malawi in East Africa. No evidence of catastrophic vegetation collapse at 74,000 years ago. Tropical ecosystems appear to have been resilient. The debate remains unresolved. What is not contested is the eruption scale. Radiometric dating using argon-argon methods places the eruption at about 73,880 years ago, give or take 320 years. The volume is constrained by caldera dimensions and ash distribution. 2,800 cubic kilometers is the minimum estimate. Some models suggest as much as 5,000 cubic kilometers. For comparison, the 1991 eruption of Mount Pinatubo in the Philippines ejected about 10 cubic kilometers of material and cooled global temperatures by roughly half a degree Celsius for 2 years. Toba was about 280 times larger. The caldera is still active. Samasir Island in the center of Lake Toba is a resurgent dome. It has been rising at about 5 millimeters per year for the last 500 years. Magma is accumulating beneath the caldera. Seismic monitoring detects regular earthquake swarms. Gas emissions from fumaroles show elevated helium-3 to helium-4 ratios, indicating a mantle source. The caldera that may have nearly ended humanity 74,000 years ago is recharging. But Toba was not the worst. 251 million years ago, another volcanic province nearly sterilized the planet. Number 6, the Siberian Traps. About 252 million years ago, give or take 100,000 years, the largest flood basalt province in Earth's history erupted across what is now central Siberia. About 4 million cubic kilometers of basaltic lava, enough to bury the continental United States under about 400 meters of rock. The eruptions covered roughly 7 million square kilometers, an area larger than Australia. The main eruptive phase lasted less than 1 million years. Some estimates shrink the main phase to under 100,000 years. On geological timescales, this is instantaneous. The magma did not just erupt through rock, it intruded through coal deposits and evaporite layers. Henrik Svensson and colleagues documented the mechanism in 2009. When basaltic magma contacts coal, the coal combusts. When it contacts evaporites, the minerals decompose. Both processes release massive quantities of greenhouse gases, carbon dioxide, methane, sulfur dioxide, halogens. The atmospheric loading was unprecedented. Douglas Irwin calculated the extinction toll in 2006. About 96% of all marine species disappeared. About 70% of land vertebrate species vanished. This is the end Permian mass extinction, the Great Dying, the worst mass extinction in Earth's history. Nothing before or since has come close. Trilobites, which had survived 300 million years and multiple previous mass extinctions, were finally erased. Eurypterids disappeared. Most brachiopod families were destroyed. Reef-building organisms were annihilated. The reef gap that followed lasted about 10 million years. Jonathan Payne and colleagues documented in 2004 that reef ecosystems simply ceased to exist for longer than the entire current age of mammals. The kill mechanisms were multiple. Global temperatures rose by roughly 8 to 10 degrees Celsius. Yudong Sun and colleagues used oxygen isotope data from conodonts in 2012 to reconstruct ocean temperatures. Tropical sea surface temperatures reached about 40 degrees Celsius, lethal to virtually all marine life. The tropics became a dead zone. Ocean acidification drove pH levels down by an estimated 0.7 units. Jonathan Payne and colleagues calculated this in 2010 using carbon isotope data and carbonate saturation modeling. Calcium carbonate shells and skeletons dissolved. Oceanic Euxinia spread across roughly 90% of the global ocean floor. Katja Meyer and colleagues identified the biomarker evidence in 2008. Anoxic hydrogen sulfidesaturated water. No aerobic life could survive. The carbon isotope excursion at the Permian-Triassic boundary is one of the largest in the geological record. The global carbon cycle did not just shift, it broke. The timing is constrained by radiometric dating. Seth Burgess and colleagues refined the chronology in 2017 using uranium lead dating of zircons. The main extinction pulse unfolded over about 60,000 years. Rapid on geological timescales, slow enough to be agonizing. Recovery to pre-extinction biodiversity took about 10 million years, the longest recovery of any mass extinction event. The survivors were predominantly small, generalist species, disaster taxa. Wistrosaurus, a pig-sized dicynodont, became so dominant that it made up an estimated 95% of all terrestrial vertebrate individuals, an unprecedented ecological monopoly born from annihilation. The removal of dominant synapsid lineages created the ecological vacuum that Archosaurs filled. Archosaurs produced dinosaurs. Dinosaurs dominated for 165 million years until their own extinction event. The mammals that survived that extinction, small, marginalized, nocturnal, eventually produced primates, then hominins, then us. Without the Great Dying, the evolutionary pathway from synapsid-dominated Permian to mammal-dominated Cenozoic would not have occurred. The atrocity that killed 96% of marine life is the reason we exist. Lee Kump compared current carbon dioxide emission rates to the conditions leading up to the end Permian in 2018. The parallels are not exact. They are not comforting. The Siberian Traps reshaped a continent. They nearly sterilized the planet. And the mechanism, flood basalt volcanism driven by mantle plumes, remains active. But 240 million years later, a smaller eruption would reshape European civilization. Number 7. The Laacher See eruption. About 12,880 years ago, give or take 40 years, a VEI 6 eruption detonated in what is now the Eifel volcanic field in western Germany. About 20 cubic kilometers of tephra were ejected into the atmosphere. The eruption created a caldera about 2 kilometers across. It is now Laacher See, a lake near Koblenz about 24 kilometers northwest of the city. The ash traveled across Europe. Hans-Ulrich Schmink and colleagues mapped the tephra distribution in 1999. Ash layers are detectable from northern Italy to southern Sweden, from eastern France to western Poland. A fallout zone covering about 1 million square kilometers. The eruption sequence was complex. Initial Plinian phase, a sustained eruption column reaching roughly 30 to 40 kilometers into the stratosphere. Pumice fallout across the region. Pyroclastic surge phase, ground-hugging density currents traveling at hundreds of kilometers per hour. The Rhine Valley was filled with pyroclastic deposits up to 20 meters thick in places. Caldera collapse phase, the magma chamber roof collapsed, creating the marsh structure visible today. The Rhine River's drainage was temporarily altered. Pyroclastic deposits blocked tributary. Lakes formed behind volcanic dams. When the dams breached, secondary floods carved new channels. The human impact was catastrophic. Michael Bowles and colleagues documented settlement abandonment in 2002. Alarod period sites, late Paleolithic hunter-gatherer camps, show occupation immediately before the eruption and abandonment during or immediately after. Stone tools, hearths, and organic remains are buried beneath the tephra layer. No evidence of reoccupation for decades to centuries. The population was displaced. Where they went is unknown. The archaeological record shows a gap. Radiocarbon dating of charcoal beneath the ash layer provides precise chronology. The eruption occurred about 12,880 years ago during the Alarod interstadial, a warm period between glacial advances. Pumice geochemistry fingerprints the source. High potassium, high silica, specific trace element ratios. Every tephra layer with this signature traces back to Laacher See. The debate over eruption duration remains unresolved. Some researchers argue the eruption lasted days. Others suggest weeks. The stratigraphic evidence supports multiple eruptive phases, but the time gaps between phases are uncertain. What is not contested is the eruption's scale. VEI 6 places it in the same category as the 1991 eruption of Mount Pinatubo in the Philippines and the 1883 eruption of Krakatoa in Indonesia. Both caused measurable global cooling. The Eifel volcanic field is still active. Hans-Ulrich Schmink documented ongoing carbon dioxide degassing in 2007. Gas emissions from the lake bottom. Elevated carbon dioxide concentrations in groundwater. Seismic monitoring detects regular microearthquakes. The volcanic system is not extinct. It is dormant. The caldera that devastated late Paleolithic Europe 12,880 years ago sits just 24 kilometers from a modern city of about 110,000 people. You can swim in it. You can hike around it. But the next threat is not in the past. It is being monitored right now. Number 8. The Lake Bonneville flood. About 14,500 years ago, the largest lake in North America catastrophically drained through Red Rock Pass in what is now southern Idaho. Lake Bonneville covered about 51,000 square kilometers of the Great Basin, approximately the size of Lake Michigan. At its deepest, the lake was about 300 meters deep. It held about 10,000 cubic kilometers of water. The outlet at Red Rock Pass eroded. The threshold failed. The lake drained. Harold Malda documented the flood mechanics in 1968. Peak discharge reached about 1 million cubic meters per second, roughly 15 times the combined flow of all rivers on Earth today. The flood carved the Snake River Canyon. The erosion was catastrophic. Bedrock channels about 100 meters deep were scoured in days to weeks. The floodwater traveled about 700 kilometers downstream, reshaping the entire Snake River plain. Jim O'Connor and colleagues modeled the hydraulics in 1993. Flow velocities exceeded 30 meters per second. In narrow sections, flow depths reached about 120 meters. The flood transported boulders weighing hundreds of tons. Basalt blocks about 10 meters across were moved dozens of kilometers downstream. The erosional features are visible today. Dry falls in the Snake River Canyon, cataracts carved by the flood and now abandoned. Melon gravel, rounded boulders deposited by the floodwater. The Great Basin was permanently reshaped. Lake Bonneville dropped by about 100 meters in a matter of weeks. The lake stabilized at a lower level, eventually evaporating to form the Great Salt Lake and other remnant water bodies. The outlet channel at Red Rock Pass is still visible, a massive breach in the basin rim carved by the catastrophic drainage. Radiocarbon dating of organic material and flood deposits places the event at about 14,500 years ago, during the last deglaciation. The mechanism is understood. The lake level rose as glacial meltwater accumulated. When the water overtopped the lowest point in the basin rim, erosion began. Once erosion started, it accelerated. The outlet channel deepened. Discharge increased. The positive feedback loop continued until the lake dropped below the outlet elevation. Modern analogs exist. Glacial Lake Missoula drained through a similar mechanism about 1,500 years earlier. The 1996 Grimsvötn flood in Iceland followed the same pattern on a smaller scale. But Lake Bonneville was larger than Missoula. The discharge was sustained for weeks, not days. The Snake River Canyon, one of the deepest river gorges in North America, was carved primarily by this single flood event, not by millions of years of gradual erosion. The Great Basin's topography, its drainage patterns, its sediment distribution, all bear the flood's signature. But 12,000 years earlier, an eruption on the other side of the Pacific would reshape an entire island. Number 9, the Oruanui eruption. About 26,500 years ago, the largest volcanic eruption in the last 70,000 years detonated in what is now the center of New Zealand's North Island. A VEI-8 eruption. About 1,170 cubic kilometers of material were ejected. The eruption created the Taupo caldera, about 35 kilometers long and 25 kilometers wide. It is now Lake Taupo, New Zealand's largest lake. The ash blanketed the entire North Island. Colin Wilson and colleagues mapped the distribution in 2006. Deposits exceed 200 meters thick near the vent. Ash layers between 1 and 10 meters thick extend across about 30,000 square kilometers. The eruption sequence was complex. Initial phase, a sustained Plinian eruption column reaching about 50 kilometers into the stratosphere, pumice fallout across the North Island. Pyroclastic flow phase, density currents traveling at hundreds of kilometers per hour. The flows extended at least 80 kilometers from the vent, incinerating everything across the central North Island. Caldera collapse phase, the magma chamber roof collapsed, creating the structure visible today beneath Lake Taupo. The North Island's topography was permanently altered. River drainages were buried under tens of meters of pyroclastic deposits. New drainage patterns formed after the eruption. The Waikato River, New Zealand's longest river, was rerouted by the eruption deposits. The human impact is uncertain. New Zealand was not inhabited by humans 26,500 years ago. The first Polynesian settlers would not arrive for another 25,000 years. But the eruption's atmospheric impact was global. Graham Mortimer and colleagues analyzed ice core records in 2018. Sulfate aerosol spikes in Antarctic ice cores correlate with the Oruanui eruption timing. Global temperatures likely dropped by roughly 1 to 3 degrees Celsius for several years. The tephra geochemistry is distinctive. High silica, high potassium specific trace element ratios. Every ash layer with this signature in the Southwest Pacific traces back to Oruanui. Radiocarbon dating of charcoal beneath the ash layer provides precise chronology. The eruption occurred about 25,360 years ago, give or take 160 years, during the last glacial maximum. The magma volume is constrained by caldera dimensions and deposit thickness. About 1,170 cubic kilometers of dense rock equivalent makes it larger than Toba's youngest eruption and comparable to Yellowstone's Lava Creek eruption. The eruption was about 100 times larger than the 1815 eruption of Tambora, which caused the year without a summer. The Taupo volcanic zone remains active. The most recent major eruption occurred in 232 CFE, a VEI-7 event that ejected about 120 cubic kilometers of material. The caldera that reshaped New Zealand's North Island 26,500 years ago is still volcanically active, monitored by GeoNet New Zealand's seismic and deformation networks. But 21,000 years later, the Mediterranean basin would experience its own catastrophic transformation. Number 10. The Zanclean flood. About 5.3 million years ago, the Mediterranean Sea did not exist. Or rather, it had stopped existing. For roughly 600,000 years, The basin that would one day host Egyptian, Phoenician, Greek, and Roman civilizations was a sun-scorched pit of salt and silence. The Mesitian salinity crisis had sealed the Mediterranean off from the Atlantic. Tectonic uplift at the Strait of Gibraltar pinched the connection shut. Without oceanic inflow, evaporation did the rest. The sea shrank. It retreated into hypersaline lakes. And eventually, in many areas, it vanished entirely. What it left behind was a wasteland. Salt deposits up to 3 kilometers thick, the crystallized residue of an ocean that had boiled away under the African sun. The basin floor, now exposed, sat roughly 3 to 5 kilometers below the surrounding land. At that depth, adiabatic heating pushed temperatures to between 50 and 80 degrees Celsius. Nothing vertebrate could survive there. Then the Atlantic broke through. Up to 90% of the water transfer may have occurred within a span of months to about 2 years. At peak flow, the channel at Gibraltar carried about 100 million cubic meters of water every second. That is roughly 1,000 times the discharge of the Amazon River, the largest waterfall in known Earth history. The erosion channel it carved is still visible in seismic surveys of the strait, a deep incision in the bedrock extending hundreds of meters below the current seafloor. Mediterranean sea level rose by about 10 meters a day at peak flow. Anything living in the basin was obliterated. Aaron Micallef and colleagues identified a massive erosional canyon off Malta in 2018, about 5 kilometers wide and 20 kilometers long, consistent with catastrophic flooding on an almost incomprehensible scale. Not everyone agrees it happened this fast. Jean-Pierre Suck and colleagues proposed in 2011 that the refilling was gradual, unfolding over thousands of years. The debate mirrors a similar controversy about the Black Sea. It remains unresolved. But the physical evidence, the erosion channels, the sediment distribution, the abruptness of the faunal turnover increasingly favors the catastrophic model. During the dry period, land bridges had connected Africa to Europe across the empty basin. Hippopotamus, elephant, and rodent fossils found on Mediterranean islands, Sicily, Sardinia, Crete, and Malta, are evidence of these crossings. Island dwarfism subsequently produced miniature elephants and giant rodents, evolutionary oddities born from isolation. When the flood came, those bridges vanished. The biogeography of the entire region was rewritten. Wout Kriegsman and colleagues established the precise dating in 1999 using astrochronology, calibrating sediment cycles against Earth's orbital parameters. The salt deposited during the crisis represents about 5% of all dissolved salt in the world's oceans. The Mediterranean's evaporation measurably reduced global ocean salinity. The Zanclean flood created the Mediterranean. Every harbor, every trade route, every naval empire that would ever exist around its shores was made possible by this single catastrophic refilling. The stage was built in months. What happened on it would take millions of years to unfold. The mechanism that dried the Mediterranean tectonic closure of the Gibraltar Strait remains active. The African and Eurasian plates continue to converge. The strait could close again. 10 events. Asteroid impact, flood basalts, glacial outburst floods, submarine landslides, supervolcanic eruptions, ocean basin refilling. Every mechanism is still active. Impacts on the scale of Chicxulub happen roughly once every 100 million years. The next one is not predictable, but detection systems improve. Flood basalt provinces erupt on timescales of roughly 10 to 100 million years. No precursor detection exists. Glacial outburst floods will return with the next ice age. The current interglacial has lasted about 11,700 years. Submarine landslides occur on timescales we cannot predict. Similar unstable slopes exist off Norway, California, Hawaii, and the Canary Islands. Supervolcanic eruptions recur roughly every 100,000 to 1 million years. Yellowstone, Toba, Campi Flegrei, all monitored, none predictable. The Mediterranean could theoretically dry out again if Gibraltar closes. The timescale is millions of years, but the mechanism is active. Stephen Sparks summarized it in 2003. We can identify hazards, we can monitor activity, we cannot predict timing. The gap between monitoring and prediction is not a failure of technology. It is a fundamental limitation. Continental reshaping continues. Plate tectonics, erosion, volcanism, all operating right now. The Phlegraean Fields caldera has recorded more than 16,000 microearthquakes between 2023 and 2025. About 3 million people live on top of it. The Atlantic meridional overturning circulation is measurably weakening. Greenland's ice sheet produces freshwater pulses into the North Atlantic. Current carbon dioxide emission rates approach end-Permian levels. The comparison is not exact. It is not comforting. Understanding the mechanisms provides no control. It provides recognition. The laws of physics that govern these events are indifferent to human civilization. Understanding them is the only advantage any species has ever had. If this one stayed with you, like and drop a comment where you're watching from. Subscribe for more.